On today's final episode for Unit 1 of Geometry, today we'll be talking about three-dimensional figures. Three dimensions? Whoa, dude, I just figured out two. So there are different types of three-dimensional solids. So the first one we're going to talk about is a solid with all flat surfaces that enclose a single region of space. That's called a polyhedron. Each flat surface or face is a polygon. The line segments where the surfaces intersect are called edges. And the point where three or more edges intersect is called a vertex. So we'll see on this diagram here, each one of these different pieces of a three-dimensional solid. Again, this entire part here that would encompass this section or this side of the polyhedron is a face, right? So that would be that entire piece there. Okay. Edge, where two sides meet. So here's an edge. And then our final piece of the puzzle is the good old vertex. Okay. So taking a look at this chart here, we can see a prism is a polyhedron with two parallel congruent faces called bases connected by parallelogram faces. Okay. So the shapes that are not necessarily, they could be any number of sides, three or more, but each side, the faces are all parallelograms. Okay, a pyramid is a polyhedron that has a polygonal base and three or more triangular faces that meet at a common vertex. Now, we have other types of three-dimensional solids that are not polyhedrons. So a cylinder is a solid with a congruent parallel circular base connected by a curved surface. Cone is a solid with a circular base connected by a curved surface to a single vertex. And then lastly is a sphere. And that's basically the set of all points in space that are the same distance from a given point. A sphere has no faces, edges, or vertices. All right, so in addition, within polyhedrons or polyhedral, if they're plural, we name them by the shape of their bases. If the sides of the polyhedron are parallelograms, as we see here for these three, those are known as prisms. These are prisms. If the sides are all triangular, these are known as pyramids. All right, so a polyhedron is a regular polyhedron if all of its faces are regular congruent polygons and all of the edges are congruent. There are 5 types of rectangular polyhedrons called Platonic solids because the ancient Greek philosopher Plato used them extensively. He studied them in great depth. So there are 5 of these. The first one is a tetrahedron, which all 4 faces are equilateral triangles. The hexahedron, or the cube, which is what most of us are familiar with, those have 6 square faces. The octahedron, or octahedron, is made of 8 equilateral triangular faces. The decahedron has 12 regular pentagonal faces. And the final one is icosahedron, which is 20 equilateral triangular faces. If you are a Dungeons and Dragons player, you will recognize that after cubes, actually all 5 of these platonic solids will make up different types of dice that are played with in the Dungeons and Dragons game. Just a bit of nerd trivia there for you. And I'm a nerd. Sorry. All right. So determine whether the solid is a polyhedron and identify the type of solid this is. So in looking at this, I have a rectangular sides, 4 rectangular faces on this over what appears to be 2 square bases. So is this a polyhedron? Yes, this is a polyhedron. And we would say the type of solid that this is, that would be a rectangular prism. Okay, let's see what you can pick here. Is this solid a polyhedron? And what type of a solid is it? Go ahead. I'll wait. Okay. Well, is it a polyhedron? No. But it is a solid, and we call that solid a cylinder, right? Is this a polyhedron? And then can you identify the type of solid it is? Again, I'll wait. All right. Is it a polyhedron? Yes. This is a yes. The type of solid. This is a triangular pyramid. Now, some of you might be wondering, is it a tetrahedron? We don't know. We can't state whether it is or not because we don't know whether all of the sides are equilateral and equiangular triangles, right? So since we don't know that, we cannot state that whether or not it is a tetrahedron. Is this solid a polyhedron? And if it is, well, no matter what, identify the type of solid this is. Okay, so is this a polyhedron? Answer, no. And what's the type of solid? It is a cone. It is a cone. Okay, is this solid a polyhedron? And what type of solid would it be? The answer to that is yes, this is a polyhedron. And what's the type of solid is it? Well, since the 2 faces or the 2 bases are triangular, this is a triangular prism. Okay, now we want to discuss surface area and volume. So surface area is a two-dimensional measurement of the surface of a solid figure. The volume is the measure of the amount of enclosed space by a solid figure. Okay. Think of surface area as how we would wrap a gift, right? How much paper would be required to wrap the entire gift, all right? The volume, how many cubic feet is in a room, okay? Or in a space. So the volume, how much space is taken up. So you'll see here we have different formulas for each one of these. And we do want to be aware that each one of these, all right, so S in each one of these represents the surface area, P is a perimeter, V is volume, B is the area of the base, H is height, L is slant height, and R is radius. L is an interesting thing because L would be this distance down this edge of this right here. If you see L in green, that's this edge. Okay. Okay. So all of these formulas, you don't need to memorize all of them. Okay. But as many as you can memorize, you do want to. The one I'm going to tell you, if you notice something here, this is rather interesting. If you look at the volume of this, right, the base times the height, 1/3 the base times the height, okay? The height, by the way, goes down from the vertex to the middle of this polygon here, okay? So 1/3 base times the height. If you take a look at the volume of the cone, it is 1/3 pi times the radius squared times the height. Okay, the area, right? B is the area of the bottom times the height. Over here is 1/3 pi r squared is the area of the circle. So there's an interesting connection between the two of these. All right, so the question asks us to find the surface area and the volume of the square pyramid. This is an important piece of data right here, square pyramid. So we know what this tells us is the base of the pyramid is a square. Well, why is that important? Well, what it tells us is that if this side is 6, then this side is also 6, right? So we want to keep in mind our formula for surface area. And there it is. So S is equal to 1/2 the perimeter, P, times the length, the surface length, which is in this case. So this is equal to L, right? 4 is equal to the height, which is H. All right, so now we just need to plug in. So the surface area is going to be equal to 1/2 of the perimeter. Well, the perimeter is 6 times 4 because it's each side is equal to 6, so that'd be 24, times the length, which is 5, plus the area of the base, which is 6 times 6, which would be 36. So the surface area here is 1/2 times 24 is 12. 12 times 5 is 60 plus 36. So that's going to be equal to 96 square centimeters. Okay. Let's do now the volume. And there's our volume. So again, it's 1/3 the base times the height. So we've already figured out that the volume is 1/3. The base area again is 6 times 6, that's 36, times the height, which is 4. So we can multiply this through. 1/3 times 36 is 12. 12 times 4 is 48. And this would be centimeters cubed. Okay, so now we want to find the surface area and volume for this cylinder. So using your chart, go ahead and do this problem on your own, and we'll come back in a moment and go through it together. Okay, so the surface area formula is 2 pi RH plus 2 pi r squared. So this is r, that's the radius. 18 is the height of the cylinder. So we're just going to plug in here and we're going to say 2 times pi times the radius, which is 6, times the height, which is 18, plus 2 times pi times the radius squared, which is 6 squared. All right, so we're going to continue this. We're going to clean this up. So this is equal to 2 times 6. We're going to figure out in terms of pi here. So let me go through this here. So with our calculator, 2 times 6 times 18. And I've got 216 pi. Plus 6 squared is 36 times 2 is 72. And that's pi. Now here's a little trick to cut down on the amount of stuff you have to type into the calculator. I can add 216 plus 72. So 216 plus 72. I've got 288. So the surface area in terms of pi is 288 pi. Okay. Now they asked us to go to the nearest tenth, so we would just take 288 and multiply it by pi. And we would end up with 904.77. So the surface area is approximately 904.8 square feet. Okay. Now, our formula for volume is a little less involved. So the volume equals pi r squared times the height. So that's just going to be volume is equal to pi times 6 squared times 18, right? So 36 is what 6 squared is equal to, so 36 times 18, and I end up with 648 pi. So now you can just multiply that by pi, and we end up with 2,035.75, which would be rounded up to 0.8, and that's cubic feet. Okay, find the surface area and volume to the nearest tenth of this prism. So go ahead and do that now. Okay, so now the surface area, the formula for surface area of a prism is the perimeter times the height plus 2 times the bases. Okay, so this would be a base here, and this is the other base here. Okay, so the perimeter, okay, is 5.2 centimeters times or plus 10, right? So the perimeter, we can just figure that out on here. Even we could say the perimeter is 2 times 5.2 plus 10, which would be 15.2, and that would be 30.4, I'm pretty sure. 15.2 with my calculator. 15.2 times 2. I got 30.4. Yeah, I'm not losing my mind. All right, so the perimeter times the height. So this is 30.4. Right? Okay, so this is equal to 30.4. The height is 6 plus 2 times the base. Well, the base area is 6 times pi 5.2. So 6 times 5.2. And I got 31.2. So we can go ahead and clean this up, and we can say 30.4 times 6, that comes out to 182.4, plus 2 times 31.2, and that's 62.4. So our surface area is 182.4 plus 62.4. That's 244.8. Okay. The volume is length times width times height, or we would also say B times the area of the base times the area of the height. So the area of the base is the base is 5.2 times 10. That's 52. So we would say the volume is equal to 52 times 6. So my volume, multiply 52 times 6, I get 312 cubic centimeters. This would be centimeters squared here. All right, now we've got a cone. Surface area and volume to the nearest tenth, right? So we can label things here. This is height. This is the slant length, L, and 15, that's our radius. So once we've properly labeled these, now you should be able to go to work. So go ahead and solve for the surface area and volume of our cone. Okay, so the formula for surface area is pi times the radius times the length plus pi r squared. So surface area is again pi times the radius, which is 15, times the length, which is 17, plus pi times 15, and we're going to square 15. So surface area again. So we just take our calculators, 15 times 17, and I've got 255 pi plus 15 squared is 225 pi. So we can treat pi like a variable here and add these coefficients of pi, and that's going to be equal to 255 plus 225. That's 480 pi. Okay, so now we can go ahead and punch that in because we want to solve to the nearest tenth. So this is approximately, and we would say 480 pi in our calculator. That comes out to 1,507.96. Now, little hint here. So if we take that and we round it to the nearest tenth, we would say this would be 1,500. Well, 6 rounds 9 up to 10. 10 as a decimal is going to add 1 onto our next one here. So we would say 1,508.0. Now you might be thinking, hey, wait a minute, why have I got to put this 0 down? Well, what it does is that shows that we rounded to the 10th. Okay? So the volume again for a cone is 1/3 pi r squared times the height. So we're just going to punch that in. Volume is equal to 1/3 pi. The radius squared is again 15 squared times the height of 8. All right, so we can rewrite this in order like this. Just here's a little hint. I've got 1/3 times 15 squared is 225 times 8. So you can go ahead and punch that in just like that, right? So make sure you use the proper buttons on the graphing calculator, and we will show you those in class. But we've got 1/3 times 225 and times 8. Oh, by the way, pi has to go on the end. That comes out to 600 pi. So the volume is 600 pi. So now to round to the nearest tenth, we're just going to take 600 and multiply it by pi. And I've got 1,884.95 again. So this rounds up to 1885.0. Okay, this would show we round to the nearest tenth. All right, so the diameter of the pole Mr. Sato purchased is 8 feet. The height is 20 inches. Find the surface area of the pole. Well, we've got a couple of different things here we have to deal with, and the first one is we have 2 different measurements here. We've got feet down here, but inches here. We've got to be in the same units. So if I take this and I go with here's my radius. This could be 4 feet, which is also equal to 48 inches. Right? Now, 20 inches could also be 1 2/3 feet, right? Because 1 foot is 12 inches, and then 20 minus 12 is 8. So 8 over 12 is equal to 2/3. So 1 2/3 feet there. Now, it doesn't matter which one you want to work with, but I'm thinking we're going to be better off working in inches because we do have a calculator. It'll still work for us. So we're going to go ahead and use that. Our formula that we want to use is area equals 2 pi RH plus pi r squared. Now, the formula given in our chart is 2 pi r squared. Well, a swimming pool doesn't have a lid on it, so you don't want it to, right? It'd be pretty painful to be doing a cannonball in a pool with a lid. So we only do one circular area, and that's going to be on the bottom. So let's go ahead and use our 48 inches, right? So our area here is going to be 2 times pi. Our radius is 48 inches. Our height is 20. Plus pi times the radius, which is 48 squared. Now we're going to get some big numbers, but we're using calculators, so that's not going to be an issue. So our surface area is 2 times 48 times 20, and that's 1,920. Pi. Plus 48 squared comes out to 2304 pi. 2,304 pi. So we're going to add those together, and we're going to end up with 2 times, let me try again. 1,920 pi plus 2,304 pi. That's 4,224 pi. So now we can figure out to the nearest tenth just by multiplying that value, 4,224, and multiplying it by pi. I get 13,270.08. So 13,270.1. inches, so square inches. Okay. Now the diameter of the pool again is the same. The height is 20 inches, but the pool is filled with water up to 16 inches high. So what is our answer, right? And we're looking for how much water, basically, right? How much water is in the pool. So our volume again is pi r squared times the height. So volume is equal to pi times the radius. Now, again, we've got to keep in mind our radius is 4 feet, which is 48 inches. Okay, because we want to have that be identical. So pi times the radius squared. So 48 squared times the height, which is 20. So the volume is equal to 48 squared. I punch in the calculator, I get 2,304, and I multiply that by 20, and I got 46,080. 46,080 pi. So now we're going to multiply those two together, and I get my volume is approximately 144,764.58, which will round up to 0.6, which will, we'll keep, 764.6. And that is in cubic inches. Now, if you wanted to convert that into cubic feet, 12 times 12 times 12 is how large a cubic foot is in inches. So you would have to divide that value 144,764.6, and I would have to divide that by 1728. Well, I couldn't get that out. That was not a very good display. So that's a very big difference in the numbers. So that volume would be 83.8 cubic feet. All right, Jessica is making a spherical candle using a wax mold that is 10 centimeters in diameter. Find the volume of wax that was needed to fill the mold to the nearest tenth. Also find the surface area of the finished candle to the nearest tenth. So go ahead and calculate that right now. Okay, let's check your work. So the surface area is equal to 4 times pi r squared. Well, that's not that bad in this case. Now, if the mold is 10 diameter, what's the radius is equal to 5. So our surface area is 4 times pi times 5 squared, right? So surface area is 4 times 25 squared is 25 times 4, it's 100 pi. So if we multiply that times 3.14, well, we multiply times 5, we get 314.15, which would be, so the surface area is approximately 314.2. Now, our volume is 4/3 pi r cubed. So radius cubed. So now we just substitute in. So the volume is equal to 4/3 times, pi times 5 cubed. So I'm going to go ahead and enter that into my calculator here. 1 times 5 cubed and I end up with a volume of 166.66 repeating, or just 6 repeating pi. So you can go ahead and just multiply your prior answer by pi, and we end up with a volume of approximately 523.6. And that's centimeters cubed. This other one was centimeters squared.
In a wet barn on the farm down in Indiana, for the sycamore trees where the Wabash breezes play, what a small red pine and for a yellow moon that shines, whining on a little red barn on a farm down in Indiana way. I said Indiana way.
So that's the end of Unit 1. I thought a silly song would be a fun way to end it. So let's get ready for the test.